Hey there, welcome to the Unit 4 Test Hints Retake Review. We're going to go through the Unit 4 test questions. I'm going to help you kind of get started on each of the questions from the Unit 4 test so that when you take your retake, you can be more successful than your first attempt. Okay, so question number 1, which ordered pair lies on the graph of the exponential function f of x equals 2 times 3 to the x? And we want to choose all of the correct answers. So my little hint here was to check if an ordered pair xy is on the graph of the function, we substitute the value, the x value into the function's equation. So here's an example of this first answer, okay? So we test f of 3. In other words, we plug in 3 for x. So 2 times 3 to the third. When I multiply that, I get 2 times 27, which is 54. It's not 56, so this is not a solution to my function, okay? It's not an answer, so I wouldn't check that one. So then I'd go through and then next I would test 0. So I'd plug in 0 where x is, and I'd see if my answer is 2. If it is, I would check that guy off. And then I have to keep testing because it says to choose all correct answers. So test -1, plug in -1 for x and see if you get 1 for an answer. Then you're going to plug in 2 for x and see if you get 18 as an answer. Pick your answer choices that give you a yes to this final step. As we move through, now would be a great time to pause, finish number 1 on your test, and then come back to me as I move on to number 2. So number 2 asks which sketch matches the given function. So here's my function, 2 times 1/3 to the x plus 2. The first step asks us, does the base indicate growth or decay? Okay, because that can help us determine whether or not we're increasing or decreasing, right? So when our base value is a fraction less than 1, which happens to be the case here, 1/3 is my base, okay, that's my base. It's less than 1, that means we have a decay problem. So you have to pick, okay, which one of these is decay? Okay, so if you think that helps you narrow it down. So narrow down the growth, take away the growth answers and keep your decay answers. Next, we can find the y-intercept. So the second step, find the y-intercept. Well, where does this go through when x equals 0? Remember, your y-intercept is always when x equals 0, so I've done that right here. F of 0 equals 2 times 1/3 to the 0 plus 2. So 2 times 1 is 2, and 2 plus 2 is 4. So my y-intercept is at 0, 4 or 4. So here you can see these red marks. They show me where my y-intercept would be. So right here, I've got a growth and decay problem, so you can kind of narrow it down from there right away. You can also look at the asymptote. The asymptote here, remember the plus k at the end of my exponential function, that tells me where my asymptote is. That's that brick line, and it happens to be at +2. Okay, so also I can look for that asymptote at +2, okay, to kind of help narrow down my choices. And the one, hopefully you can see then, the one that satisfies all of those conditions. It's decaying, it has a y-intercept of 0, 4, and it has an asymptote at y equals 2. You should be able to narrow down with those 3 things given. Okay, number 3, which function's graph has a y-intercept of 1? So remember the value of x equals 0 and we're looking for the y-intercept. So for each one of these, you're going to substitute in 0 for x. You're plugging in 0, plug in 0, plug in 0. And we want to know which one of these gives us 1 for an answer. Whichever one gives us 1, that's your answer. Plug in 0 for each one. The one that gives you 1 for an answer is the correct answer. Moving on to number 4. Again, if you need to pause, do so you can finish up the previous example before moving on to the next. So number 4, the function f of x equals 2 to the x is shown on the coordinate plane. Here's my function. I want to fill in the blanks with your letter choices, okay? So follow the graph from left to right. So here's left, here's right. So as x is increasing without bound, I'm going to get my pointer here. Okay, so as x is getting bigger, what is happening to my function? Okay, is my function decreasing? Is it increasing without bound? Is it approaching the line y equals 0? Or is it approaching the line y equals 2? Okay, now really quick, the lines y equals 0 and y equals 2, this line, guys, oh man, that's not very straight. There's y equals 0, and this would be y equals 2, just kind of as a frame of reference. So I want to know what is happening as my x's are getting bigger, as it's increasing, what's happening to my function. Is it decreasing without bound? Is it increasing without bound? Or is it approaching one of these two lines? Okay, so there's the visual there. Okay, now as x decreases without bound, so as I'm getting smaller, what is happening to my function? Is it decreasing without bound? Is it increasing without bound? Or is it approaching the line y equals 0? Or is it approaching the line y equals 2? So look here as I'm decreasing. Hopefully you can kind of follow that red dot. So I'm decreasing, what is happening? And then you go ahead and fill in your answer choices. Okay, number 5. Use the function p of t equals 5 times 2 to the t to answer the question below. So which value best describes the range of the function? A little hint, range is all the values y can take. So in an exponential function, this will be all of the values greater or less than the asymptote. So if we look at this graph, we want to know, okay, what is our asymptote? What is this line approaching? Well, I look here on my y-axis, it's approaching 0, okay? So you have to tell me, is my function greater than that asymptote, or is it less than that asymptote? Okay, and then you can go ahead and pick your answer based on what we just talked about. Number 6, what is the average rate of change of the function below on the interval from x equals -1 and x equals +1? Okay, so when we're finding the average rate of change, you first have to evaluate your function at x equals -1. So g of -1, you're literally going to take your x, you're going to plug in -1. That's going to give you your y1. You're going to do the same thing with 1. Now you're going to plug in 1 for x, and that's going to give you your y2. This was your x1 and your y, and this is your x2. Once you have your answers for y1 and y2, you're going to use your slope formula to solve. You'll get your number. If necessary, write your answer as a decimal. If you get a whole number or integer, just write it as your integer. Okay, you'll probably need to pause and finish number 6 before moving on to number 7, but number 7 says that the first 4 terms of a sequence are shown. I've got 16, 48, 144, and 432. I want to know what the common ratio is for the sequence. So here's some things to think about. The common ratio is what you multiply by each time to create a pattern in a list of numbers. So think, what are you multiplying by to get from 16 to 48? What are you multiplying by to get from 48 to 145? Excuse me, 144. Okay, another way to do the common ratio, take your second term, so this is like A1, A2, A3, A4, take that second term, divide it by the first term. That tells me what my common ratio should be. Number 8, which function represents the sequence? My explicit rule for geometric sequences is right here. Okay, so a sub n equals the first term, a sub 1 times r, that's my common ratio, all to the n minus 1. I need to find the first term, my a sub 1. Here is my first term. Term number 1 is 6. Okay? Find the common ratio. This is what we multiply by to get to that next number. To find the common ratio, take your second term, divide it by your first term. That's going to give you r. Okay, then I'm just going to kind of help color code where you plug things in. So here, you can't really see that. A sub 1. Let me change it to maybe blue. I'm not helping here. Okay, I'm gonna just circle. Here we go. A sub 1, A sub 1, okay? Then my R value, okay, whatever answer you get here, you're gonna plug in right here. Then pick which answer you think is correct based on that. Notice that it's raised to the n minus 1, that doesn't change. Number 9, a certain population of bacteria has an average growth rate of 2%. The formula for growth of the bacteria population is A equals P sub 0 times 1.02 to the T. It tells me that P sub 0 is the original population and T is the time in hours. It tells me if I begin with 200 bacteria, about how many bacteria will there be after 100 hours? So we want to find the initial starting population. This is P sub 0. Well, they tell me if you begin with 200 bacteria, okay, so I know that my P sub 0 is 200. Find the time. How many bacteria will there be after 100 hours? They give me the time, 100 hours. Fill these two values into your function. Here's your P sub 0, here's your T. Plug those numbers in, simplify to solve. Pick your answer. Okay, so pause, finish number 9, and then come join me on number 10. The cheetah population in the Sahara Desert is declining at a rate of 4.5% per year. The population was 925 in the year 2005, and I want to know which answer is the best prediction of the population in the year 2012. All right, now we're using our exponential growth and decay formula to plug things into. So I need to find my initial starting population. That's going to be B. So what was my original population given to me in the problem? Well, they tell me my population was 925. Find the growth rate. As a decimal, this is R. Okay, it tells me we're declining at a rate of 4.5%. There's my rate. You have to make it into a decimal. That's your R. Remember, you divide by 100 to get your decimal. We're declining, so determine if you should use plus or minus if we're declining. And then we want to find the time, number of years that pass. This is T. We're starting in 2005, we're ending in 2012. So my total time would be the difference between those 2 years. And then we're going to fill those values into the equation. So you're going to plug in your value for B. That's your starting point. Okay? You're going to tell me if I'm going to use the plus or minus. You're going to pick one of those. If we're declining, we use a minus. If we're growing, we use a plus. My rate, whatever decimal you get here, when you do your 4.5% divided by 100, that's your R. And then your T is going to be that time difference between 2012 and 2005. That's going to give you your answer for the best prediction. Number 11, similar problem, except now we're talking about money. So an amount of $1,000 is deposited into a bank account. It pays 4% interest each year. If there are no other withdrawals or deposits, what will be the balance of the account after 5 years? We want to write our answer as money. Okay, so find the initial starting amount. This is B. Okay, they tell me how much I originally deposit into the account. There's my B. Find the growth rate. It tells me 4%. Write it as a decimal. Just like we did in the last example, we divide that by 100. Okay, it tells me that it pays 4% every year. So if it's paying me, I'm growing. Okay, so that should help you determine your plus or your minus. The time, I want to know after 5 years. There's your T. Put all that in, simplify to solve. Write your answer to the nearest penny or 2 decimal places. All right, so that sums up all of the Unit 4 test questions and hints. Hopefully this will help you with your retake and getting a better score.